Hi everyone, today we're going to talk about 4.2 measure of spread. The key element of the distribution of a numerical variables are its shape, its center, and its spread, and unusual characteristics such as outlier. So far, we compared the spread of two distributions by inspecting diagrams, histogram, bar graphs. Now, three methods that involve making computations rather than inspecting a diagram. One kind of numerical summary for a set of data is a measure of center, but the measure of the center does not tell a complete story. Data points do not always fall on or even near their center. We need a measurement of how far away from a measure of a center. We can expect to find individual observations in the data set. So let's take a look example number 1 and talk about it. Okay, a random sample of 20 test scores is recorded. Compute the sample mean, which is average, for each of the following scenario. Remember, the mean is the balancing point of the histogram. A, if every student scored 50 points, what would the sample mean be? I hope everybody will come up with the answer 50 because there's no too high than the score too high or score too low. They don't need to balance it out. The balancing point is at 50 because everybody got 50. B, if half of the students scored 0 point and half the students scored 100 points, what would the sample mean? So let's just assume the example is a 1 0 and 1 100. The same thing if you have 2 0, 2 100 because it's halfway. You will say 0 plus 100 divided by 2, and that's 100 divided by 2. Oh, it's 50 again. So in this case, what would the sample mean? Sample mean is 50 because it's average. What can you tell me based on the data? Well, I would think you should be able to tell me, say, hey, Ms. Wiesman, the sample mean is 50, but we cannot tell you which kind of data were you going to get. So we're going to put down definitions. We are going to talk about a few of them. First of all is measure of dispersion, and that's variation. And that means numerical summaries that measure the spread in the data, okay, the spread. So in this case, two ways we're going to measure dispersion. And number one is going to be the range. And the range is very important that you guys have to think about. It's not resistant. And what does that mean? That means when you have a high range or low range compared to a different kind of range, you will pull that data, you will pull that range numbers in different directions. So when they say non-resistant is if you have one that's really out there, it will change the range from the smallest number to the biggest number. So in that case, it's not resistant. It's not something that cannot be easily influenced. It's something that can be influenced very easily if you have very extreme data. And that is, to find that is the distance between the maximum and the minimum value in the data set. So the formula is we use big letter cap R equals the largest observation minus the smallest observation. So just pretty much the max minus the min. So let's talk about that. The size of the household for 5 different students are 2, 3, 4, 6, and 10. That means how many people is in your house. The range will be the biggest number, 10 minus 2, the small amount of people in your house, and that's A. And this is important to state the units for the range. Okay, the biggest number minus smallest number. That's it. Example number 2. Vehicle sales in April 2014 are shown in the table below for each automaker. A. Find the range in sales and explain what it means in the situation. So if you look at the numbers, you should be able to find the the largest, General Motors, and that's 254,076 cars. Let's write that down. That's the maximum minus the least amount car was sold is Subaru, and that is 40,083. And when you put them when you subtract them, the answer is going to be 213,993. So once we find 213,993 vehicles was the range, what we can answer the question, it says explain what it means in this situation. It means this suggests that the spread of the vehicle sales of the automakers is quite large, and that's what the spread of the from how many cars being sold by each company is huge. So I'm gonna pause this and write it down, and you guys can copy it. Okay, talk about the quartiles. Okay, first thing, lower quartiles is the first quartiles, the median of the lower half of the data. Okay, that means if the median is in the middle, the lower half of the median. Well, median is at 50%. So in this case, when they say quartile, lower half, that's really what's a half of 0 between 0 and 50? 25. So that's actually the first quartile is at 25%, if you can keep that in mind. Okay, and then middle quartile, that's the second quarter. That's the median, which is the 50% that we talked about before of the whole data set. Okay, and the next one is the upper quartile. The upper quartile is between the median, which is 50% of 50 to 100, so therefore 75. So in this case, if you want to think about it, this is like the 25% mark, this is like the 50% mark, and this is about the 75% mark. Definition of an interquartile range, and that is going to be IQR. An IQR is going to be what they say between 25% lower quartile to 75% upper quartile or the third quartile. Okay, so in this case, if you want to think about 25% at first quarter, 50% on second quarter, 75% third quarter, and the interquartile IQR is between this one and this one. That is the third quartile. IQR. Hope that helps. Example number 4, compute the range for data set A and for data set B. I also am asking you to figure out what is the quartile, first quartile, third quartile, and IQR, and we're gonna compare them. Okay, so here we go. N is, remember, stand for the little n, which is sample. How many sample is there? So in this case, if you count it, that should be 10. And the range, now the range probably is gonna be find the biggest minus the smallest. That's the definition of range. So I'm gonna say biggest is 20, the smallest is 2, and you can say the range is 18. Now if you don't want to show work, I can totally understand because you can do that in your head. Now the next thing we're gonna look for is the quartile 1 and quartile 3 and IQR. Now before you do that, you have to make sure that you understand is the median. And since we are talking about median, we're gonna put everything in order. So if you put everything in order, you will start with 2. So that's 2, 3, 2, 3, 4, 5, 2 of them, 6, 6, and 7, and 8, and 20. And then since this is gonna be something that you find the middle, and the middle is in this case right in between 5 on one side, 5 on the other side. Right there is your meat. But because we have even number, remember, we have to add the 5 and 6 and divide by 2. Now, since we are not looking for that because we are only looking for quartile 1 and quartile 3. So by definition, the quartile 1 is the median of the first half. So median means the middle, and the middle is gonna be 2, 3, 5, 5, 4 will be your first quartile. Okay, what's the quartile 3 is the median of the second half. So therefore, median of the second half, there's 5 numbers. So the middle one will be 7. So that's Q3. And the IQR is equal to Q3 minus Q1. And in this case, it's 7 minus 4. That is 3. So we're going to fill in the numbers. So quartile 1 is 4. Quartile 3 is 7. IQR is 3. Data set B. Pause it right now and I'll show you the answer in a minute. But make sure you show your work because I will be looking for that on your note for your note points. Okay, I gave you guys the answer for the data set B. So now the thing is they want you to compare what's the difference between the two set of data. Well, I will tell you right now, the two set of data, the range for data set A and data set B is data set A has bigger spread. That's all. It just the range of the numbers is wider. Okay, so we're gonna just write that down. Now, what are some of the problems? Well, problem with range calculation. The spread. This is going back to the sales of the vehicle. The spread of the vehicle sales of the automakers are quite large. And the second one is that no matter how many observations there are, the range is only taking into account only 2 observations, the smallest, the biggest. Okay, so in this case, the smallest could be really off the wall, or the largest could be really off the wall, and we wouldn't know anything in between. So it's not as accurate because you want to have more samples, then it has more true picture of everything. The second type of spread is we are going to learn to work through is standard deviation of a variable. And then so in this case you define, there's some definitions, population variance, the average square distance the population data points fall from their mean. So that is going to be just sigma squared equals summation x minus mu. Don't forget that's the x value minus the mean of the population square over capital N. Now, that's going to be a little harder to calculate, but I'll show you guys what we're going to do in a minute. Then the next one is the population standard deviation. So that is going to be taking the square root because we don't want sigma squared. So the square root of population variance. And then if you square root both sides, you guys learned from last year, that square and square root cancel each other out. So that's going to be just sigma equals square root of summation x minus mu parentheses square over big N. Now, my little bad on drawing the line, but summation should be above the line. Okay, and then the next thing what we're going to do is we are going to talk about sample variance. Okay, and that is probably the ones we're going to use the most because population is just way too hard to work with if you have tons of data and you sometimes just don't know how big the population is going to get. So the next one is called the standard sample variance. Okay, sample variance means you have a group that is manageable. So that is going to be squared, sample square equals the summation individual data point minus the mean data point squared, and then over little n, that means let the sample size minus 1. Okay, and then the next one is going to be S right here. I'm going to give you all the data. So I'm going to bring it down because we are literally going to work only with S because, again, population is too big. So, again, just do the comparison. The summation, and then we're going to go through a problem. X minus X bar, that's the average, square over N minus 1. And then do you notice that's a square? So what we're going to do is we are going to take it down so there's no S square. So S is going to be square root of the summation of X individual data minus X bar, that means the mean, which is the average, parenthesis square over the n minus 1. Okay? I'm going to show you how to do all those things in the calculator so you can get your maximum number, which is what's the highest number, what's the lowest number, what's the average, what's all those kind of things. So we're going to get all those things. And those also have a name. It's called five number summary. So we will do that all at once. So here we go. With your TI-84, you're going to start by entering all your data, and that's what you do. You go to stats, and then so go to stats, and then you can see just like what we did before, type 1 for edit. And then did you notice that I enter all my data point from the problem that we did before, and that is compare the data set A and data set B. So this is going to be the 5, 8, 20, 3, 4, 2, 5, 6, 7, 6. I'll show you where 6, 7, 6 is. 6, 7, 6. Okay, so there's 10 pieces of data right there. Now, once you do that, you can exit out, and it's so easy. You can just go to stats, because we are in stats class. Go to stat, and you're going to do calculation. Okay, instead edit, we are doing calculation. Now, do you guys remember you put your data in list 1, and then so therefore we are going to do first var stats. So that's number 1 right there. You're going to type 1, and then because we're in list 1, it will automatically pick up list 1, and there's your number. Just want to be very clear. In first var right here, that is the average x bar. This is the summation of x, means adding all the terms together. That's 66. This is x squared, that means this squared. Okay, and then this is the sample standard deviation. This is the population deviation. So usually this is the number we look for, standard deviation. Okay, and we're going to use that a lot. So you guys have to understand all this and how to get to it. Then we want to talk about the bottom right here, passing how many data pieces we have right here. This is called the 5 number summary, and we're going to be also using that. The smallest 2, the quartile 1 is 4, the medium is 5.5, the quartile 3 is 7, and the maximum number is 20. So this is called the 5 number summary right here. Okay, so just make sure you understand the vocabulary. In this case, after I just show you guys how to do it on the calculator, the number for the set A, the standard deviation, is going to be 5.037. And then the next one, you guys try it and see, did you get the same answer? Pause it if you don't want to see the answer right now. Standard deviation should be 2.700. All right, so now compare the standard deviation for the wait time for the restaurant A and restaurant B. This is restaurant A and restaurant B's wait time. Standard deviation is 5 minutes to 2.7 minutes. On average, the wait time at the restaurant A varies more from their mean than restaurant B. What does standard deviation means, and what is that compared to the mean? What they are saying is standard deviation is 5 minutes to 2.7 minutes, which is right here. Okay, then on average the wait time at restaurant A varies more from their mean. Now I put the mean right here for you guys, and what that means is saying, okay, my data point from all the piece of data right here is all the distance add together from the data piece compared to that. All the data distance from that is going to be averaged together is 5.037. And that's kind of hard to understand because of then you have a 20 piece, 20, so that's a further away. So standard deviation is measuring the points, how far they are away from the mean, and summarize them and subtract. So if you think about it, maybe this one will be a little bit better right here if you think. So this is my standard deviation. So it's 1, 2, 3, 4. It's about at 4.58. This is, let's say this is 4.58. Okay, now the 1 is down here, the 4 is right here, the 10 is up here. And what they are really measuring is how far is this distance from my mean? How far is the 4 away from my mean? How far is my 10 away from my mean? All those distance add together, square, and square rooted divide by n minus 1. So I hope that helps a little bit to explain. So this one is really, if you want to think about it, this is why standard deviation is a little bit complicated to figure out. But if you understand it, it's really a very nice way to try to figure out the distance away from it. So in this case, what you have to do is you have to think about this is the average is, oh, I just deleted it. Okay, the average is 6.54. So here's my 6.54. Let's say this is 6.54. And then I have points that's 5 down here. I have points 8 up here. I have points 20 up here. And I have points at 3 right here. And then so forth and so forth. And they are actually trying to add together the distance from those points away from the the mean. So then you do all those formulas. So that way it's measuring how far is the distance from each point of data to the middle, the average. So the data is a little bit more accurate. Average the wait time at the restaurant A varies more because they have further data point pieces. And then so the standard deviation, this one is 5.037, the other one's 2.7. So therefore the data points from the first set is further away. So therefore you have the wider range compared to the second one.